Hello, everybody. Welcome to Percona's Tech Days. I am really excited to see you guys here. This is going to be a really exciting day. It's the first of 3 tech days that we have going on, and we had such a fun time with Percona Live Online. Percona Live Online was a huge success. We decided to do a few days that were very specific and very focused on individual technologies. And today we're going to celebrate Postgres and all that is great and wonderful in the Postgres community. And we're really happy to have you here. Whether you're watching live or not, wanted to just give you a few quick updates and reminders. As I said, this is the first. We've got another MongoDB Tech Day. So MongoDB focused coming up on August 27th. And we also have a MySQL Tech Day coming up on September 10th. If you haven't joined our Slack channel, you can join the Slack channel. That's where we will be looking for any questions, any sort of Q&A. If you want to engage with other attendees, there are links available either in the comments where you're watching or on our webpage. Wanted to also highlight in another week, we're going to be giving what we're calling the Percona Roadshow, where Peter and myself are going to banter back and forth live, and you never know what's going to happen. I want you to bring your tough questions. We want to see if we can stump Peter on some MySQL or technical related questions. It's always fun to see, the depths of his knowledge because it is really, really great. Also, want to ask if you haven't subscribed to our channels here, please do. So there's a subscribe button if you're watching on YouTube or on Twitch. Please subscribe to those. We would love to update you as these new events and these new things happen. So those are always great. So without further ado, I don't want to take up any more of your time. Just thank you for coming. I want to introduce Avi, who's going to be our first speaker. Avi is our Postgres tech lead. And so Avi, are you there?
Hey, Matt. Yes, I'm here.
Lovely, lovely. Avi, take it away.
All right. Thank you for the introduction again, Matt. I would go ahead and share my screen. Okay. I assume that you're able to, could somebody confirm that you're able to see the slides?
Yes, we can see the slides.
Excellent. All right. Thank you, Matt, again for the introduction. And I'm Avi. I'm a Postgres tech lead at Percona. And without further ado, I would go ahead and start presenting. And so today we are going to talk about how we could build an enterprise-grade PostgreSQL server using Percona distribution for Postgres, right? So what is this talk all about, right? Let's consider your Postgres environments, and you are migrating from proprietary databases, let's say an Oracle, to Postgres. Now, there are a lot of assumptions that we always get to see, right? That most of the features are not free with Postgres. You may have to go with some kind of licensing or some kind of, you need to go ahead and pay in order to get some better security or high availability, or in order to do backups the right way, you may have to pay for it. But that's all assumption. So today we are going to show you how Percona distribution for Postgres has solved that, and how you could really build enterprise-grade Postgres using Percona distribution for Postgres. So just to let you know, we have Percona distribution for Postgres release for Postgres 11 as well as 12. And for 11, you could get it for the minor versions 5, 6, 7, and 8, and even for 12, the minor versions 2 and 3 are available. So you could go ahead and download them using the links, and you should be able to use them. So what's included in Percona distribution at the moment, right? You would be able to get Postgres, the community Postgres available with it, and you're also going to see some of the well-tested and Percona basically has spent a lot of time testing and making sure that the extensions as well as the tools we choose satisfy the enterprise needs and also made sure that they work the right way, right? So we got PG repack, PG audit, PG backrest, and Percona included in it, right? So you're going to go ahead and just download Percona distribution for Postgres, and you're going to see all of these included within it. So we're going to see what these extensions or tools do and how it helps to build an enterprise-grade Postgres shortly. But before going ahead with that, I would quickly go ahead with some of the myths that we come across and how you could really overcome all of that and deploy Postgres and start using it happily. So some of the myths that we usually hear in the Postgres world are security is not free, or we cannot take a full backup that is good for point in time recovery. We cannot set up a high availability. It's not scalable. Options for database maintenance, such as if you want to rebuild a table or perform some maintenance operation, you may have to go through some downtime. And there actually, I've just put a very short list here, right? So there are many more that we usually hear too. For example, I would want to port my application from Oracle to Postgres, and I need to use some functionalities that are only available with Oracle. For example, some of the DBMS functions, right? So most of these problems were already faced by somebody in the past, and somebody already worked on it. When I say somebody, it's not just one person. Many who have always wanted to migrate away from Oracle to Postgres for various reasons have always contributed back with the solutions of their problems, right? Or to their problems. So we have great extensions that even give a lot of compatibility for a lot of Oracle syntax, right? So you would be able to go ahead and even deploy such extensions, which are available as open source. So you really don't have to go for some kind of an enterprise licensing in order to get all such features. So what are the usual enterprise-grade Postgres features that we hear, right? So some features such as encryption, user management, wherein you do a proper segregation of users and roles, the ability to tune your database, right? So, and there is a much more bigger list, right? You want to go ahead and implement load balancing, scale your databases, and at the same time, implement connection pooling, do a proper auditing, monitoring, and build high availability using robust replication methods. And you also want to enable great reliable backups and perform maintenance tasks, partitioning, and you would also wish to see continuous bug fixes, and also want to make sure that any security vulnerabilities, if they're observed, you want to go ahead and get the fixes for that incorporated to your database software. So all of these are mostly some of the enterprise-grade features somebody would expect for any database and even for Postgres. Now, the question is, do you have to pay to get all of these? The answer is no. Let's see how, right? We'll discuss most of them in this 30 minutes webinar or the talk, right? So some of these are already blogged and available on Percona blog posting platform, like how you could secure your Postgres database cluster, high availability backup, connection poolers. Or we have blogged about it in the past, and you could go ahead and take a look at these blog posts too. So security in Postgres. So Postgres by default includes a lot of features that satisfy a lot of security standards. You have a built-in firewall, which is nothing but the host-based authentication. So you could restrict which user from which IP from to which database can he connect or can he not connect, right? So you could go ahead and do much more granular settings and even implement several authentication methods. And likewise, you could also go ahead and implement user management using roles and privileges. So you could have roles created, like specifically a read-write role or a read-only role schema-specific roles or application logic-specific roles, and you would be able to assign roles. And at the same time, you would also be able to even restrict row-level access, and that's something that's available with Postgres too. That's part of the Percona distribution for Postgres, as well as the community Postgres. And you could also implement encryption using file system level encryption, of course, but at the same time, you also have an extension called PG Crypto that could help you at a great extent. And also, you could enable detailed logging and debugging with Postgres, and that's available already. And there is an extension called PG Audit, which is also part of the Percona distribution for Postgres that allows you to enable logging that's compliant, that basically compliant with a lot of ISO and all of the compliances too. So it would help us even see any kind of SQL injections, right? Or several things that you would not be able to just see with the detailed logging that you may enable. So, and that's part of Percona distribution for Postgres. And for security bug fixes, how do you know about the bug fixes or any security fixes, right? You should be subscribing to Postgres mailing list and also follow Percona blog post. Go ahead and subscribe to the Percona blog post if you haven't done yet, because we keep posting blogs about any major fixes usually, right? And also if in case we found a security vulnerability which has been fixed as part of the minor version in Postgres, right? I mean, you would usually see a blog post from us. So it's good to subscribe to the mailing list and blog posts so that you would get to know about it and you could go ahead and implement that fix. Talking about backup strategy, Postgres by default includes a consistent online backup tool, which is PG-based backup, right? And it also helps you achieve point-in-time recovery. Likewise, Postgres is also not only just the physical backup tool, Postgres has also got the logical backup tool, right? Like PG dump and restore, PG restore. And you would also be able to enable archiving, because the reason why I'm emphasizing on these tools or the archiving today is because in most of the commercial databases, you would not be able to get such solutions included with the standard versions. You may have to go ahead and choose the enterprise version of the product, right? But this is all included with Postgres. At the same time, PG-based backup may not be helpful if you have a database which is several terabytes or hundreds of gigabytes in size. And if you would want to go ahead and implement incremental backup, differential backup, or directly stream your backup to cloud. So what Percona distribution for, what Percona did is that we have gone ahead and included PG Backrest, which is another umbrella project, and it's open source. So PG Backrest is included in Percona distribution for Postgres, and that actually solves a lot of problems. For example, you would be able to perform incremental differential backups and even parallel backup, right? And you would be able to encrypt the repository, and you could basically go ahead and stream your backup to Amazon S3 or Azure Blob Store, right? So it's integrated with cloud. So PG Backrest is robust, and so that's a backup tool that you could really rely on. And it's a very active project, and yeah. Talking about connection pooling and load balancing. As you know, Postgres is process-based, and so each connection that you establish from application to Postgres is a process. So when too many connections come in from an app, and basically the activity goes on in a way that you establish a connection, you disconnect a connection, you establish another connection, disconnect the connection again. So this establishing and disconnecting, like terminating the connection, is actually an overhead in Linux. So you would rather want to prefer having an application level connection pooler, which is usually preferred, right? So if you do not have a robust application connection pooler, that is doing a good job, you could go ahead and implement external connection poolers. So you could go ahead and use the connections poolers that you see here, PG Bouncer or PG Pool 2, on top of the distribution. So it's not part of the distribution yet, but it's not that you could not use it, right? So you could use PG Bouncer, which is again open source, and that understands the Postgres protocol, very actively developed, and also a lot of Postgres community members have contributed to PG Bouncer, and you could implement that as a connection pooler and really see great benefits. At the same time, PG Pool 2 also is a connection pooler. However, that is good for performing some important or good in achieving some of the important functionalities. And one of them is if you are not able to distinguish between writes and reads, right? In that case, you would be able to go ahead and use a PG pool and let it distinguish between reads and writes from the app, and let it redirect the connections automatically to a primary or a standby. Because what really happens is that you would want to use the computing power of all the database servers, right, which are even in replication. In Postgres, you could also read from the standbys. So you would be able to go ahead and perform reads from the standby and writes to the primary. So, and you could directly connect to a PG pool too, and that automatically redirects the connections to a primary or a standby. However, there are some kind of, it's not completely automatic. You may have to go ahead and incorporate some changes to within your application, the way you do things. But based on the testing or kind of benchmarkings that we did, PG Bouncer outperforms when you just use it as a connection pooler, right? So, and you could use HA proxy like tools for, and it's open source to HA proxy. And so that can be used for load balancing between load balancing the reads between multiple standby machines or primary and standby machines. So all of these are available and heavily used by the Postgres world in order to scale the scale the Postgres instances. And there is a talk on the connection pooling shortly. I think the next talk. And talking about high availability and automatic failover, Postgres has got robust replication methods already included. So you do not have to go ahead and get some kind of an enterprise or think of an enterprise solution again. There is no need of it, right? So it has got streaming replication, which could also allow you to build cascaded replication, right? And also you could make it synchronous, asynchronous, a hot standby in the sense your standbys could accept reads. So you could use the computing power of the standby. So Postgres has got streaming replication already included. And you would also be able to configure logical replication with Postgres. And since Postgres 10, you have logical replication and logical decoding part of the Postgres source, the community version. So everything that you see here is also part of Percona distribution for Postgres, right? And for automatic failover, you have a robust HA solution, which is it's Percona, right? It's a template which can be used for achieving automatic failover. So that can be used on top of a replication cluster, which to monitor the primary and standbys and perform the automatic failover seamlessly, right? So Percona architecture looks something like this, right? So where you have 3 instances, and Percona could detect the, if in case the primary or the master goes down, it would get the consensus from a consensus key value store, a distributed consensus key value store like etcd. That's helping Percona in the leader elections, and Percona would perform the failover seamlessly. And you could use HA proxy for your application, HA proxy between your application and the Percona cluster. So HA proxy could include or could use the Percona APIs or REST APIs to determine what's a primary or what's a standby. So that way you would be able to go ahead and perform a seamless failover without any manual intervention. And this is possible with Postgres, right? So there are people who are really using it extensively, and it's deployed at several customer locations already, and everybody are happy with it. So likewise, we have seen the advantages of Percona and made it part of Percona distribution for Postgres. So you get it included, and it's an open source tool too. So talking about extensions, Postgres is feature rich and completely community driven, right? So you have the ability to add extensions that serve some purpose. For example, you have an extension called pgstat statements. So you would want to see something like AWR in Oracle, for example, wherein you want to see what happened in the past. What are the queries that have run in the past, and what was the activity, or how much memory, or how much time has it taken, right? So pgstat statements contains the query stats, right? So you would be able to go ahead and see the queries that have run, the total consumption time, and the average consumption time, or the execution time, and how much of the blocks were fetched from memory or from disk, right? So all of that statistics are available. Likewise, there is an extension called pgrepack. So sometime back, I mentioned, like, most of the problems that we think of today, if we are using Postgres for the first time, these were problems which somebody has already faced in the past, and they've contributed back. So most of the extensions that you have actually seen, or you see in the list here, of course, I haven't included a huge number of extensions here, but most of these are the contributions in that way, right? The users have contributed, and they are eventually made so robust with feedback and a lot of feature requests, etc. So pgrepack is an extension that would enable you to perform online table reorg, or you could rebuild a table online while your application is still writing to it. At the same time, you would be able to go ahead and rebuild indexes, and you could do a parallel table rebuild so that your table rebuild really goes faster, right? Because if you do a vacuum full on Postgres, it acquires an exclusive lock on the table. So pgrepack is already included in Percona distribution for Postgres, and the pgstat statements and most of the extensions that you see here are already part of the contrib module. So they are already included with Postgres if you install Postgres contrib, right? Contrib package. So likewise, there are some more extensions that you could, or tools that you could install on top of either Percona distribution for Postgres, or even the community Postgres that should help you. For example, PL Profiler. If you want to write stored procedures and you want to see at what line of code the execution is really taking time, you would be able to see that with PL Profiler. That has got a beautiful, it's a rich HTML text that you would actually see, like an HTML file, wherein you would be able to go ahead and point, at what line of code is it at a conditional where time is spent more, or is it a specific query that's taking more time within the stored procedure, or is it internally calling a function which is actually taking more time, and what's happening within that nested function. So all of that information is available with PL Profiler. And Oraface, some time back I was mentioning that you would want to port your applications to Postgres easily. And Oraface is an extension that has got lots of Oracle specific terminologies built in. For example, you want to use the dual table, for example, or there are a lot of DBMS functions, or that you would want to go ahead and use, like sysdate, or even so. All of these, if you want to still continue using in your application, and you want to you do not want to go ahead and make changes in your application, you want to make it a faster migration, you could use extension like Oraface, which is again open source, right? So you could use it for free. And there are several language extensions like not only PLPG SQL, but you could also write in Python, Perl, Java. So Postgres is extensible that way too. So whichever language you're comfortable with, you could write procedures in that language. And in order to talk to remote heterogeneous databases, you also have foreign data wrappers. So you could use foreign data wrappers as well on top of Percona distribution for Postgres, as well as the community Postgres. So these enable you to join a remote Postgres or Oracle database, a table on a remote Postgres or an Oracle database, right? So personally, like I've done data migration from Oracle to Postgres in a much faster way using Oracle FTW, right? And that's really robust. And it also helps you even convert the Oracle schema to Postgres up to a certain extent, right? So, and all of these are available for free. I mean, you do not have to pay for these extensions, right? So again, coming back to the original point, most of the features that we assume are not available for free, and that need to be part of an enterprise, kind of an enterprise version. You know, I mean, we need to realize that that's not the fact anymore, right? So most of the extensions are available for us, and most of tools are already contributed and available for free to use. So you could also go ahead and enable detailed logging of activity in Postgres, like I said some time back, and you could log DDLs, you could log statements that are running for more than a certain time, right? You could even say, I mean, you could set log min duration statement. That's a parameter which you could set to say, okay, log all the statements that are taking more than 1 second or 10 milliseconds, and you log it. And then you could use PG Badger like tools to analyze the logs, right? And it would print you a detailed report, which is so robust and also very, very clear. And most of the issues are really solved when you look at a PG Badger report. Addition to that, PMM, like Percona monitoring and management, like PMM is a monitoring solution available with Percona for free again. So it's contributed and developed by Percona. You have query analytics in PMM that would give you a greater insight into the query execution, right? Like what queries are taking how much time to complete, and how is the history of that query, right? Like how much time has it taken in the past, and some of the system resources utilization. So you could really get to a lot of granular data, and that would really help you, fix a lot of performance issues. So you could use, again, all of these for free on top of either Percona distribution for Postgres or even community Postgres. And talking about monitoring, there are several open source monitoring solutions like PMM, Nagios, and you could use even Grafana and Postgres Exporter, PG Observer. So a lot of these are available for monitoring. However, you could go ahead and try PMM today, because PMM, Percona monitoring and management. So there's a monitoring tool that's available for not just Postgres, but also for MySQL and MongoDB. So you could use or monitor a wide variety of databases or database technologies using just one monitoring tool. And so because we discussed about, a connection pooler, a load balancer, a high availability and automatic failover solution, and monitoring. So you could build a robust Postgres architecture that actually looks like this, right? So you have PG Bouncer as a connection pooler deployed on the application server, and that's talking to HA proxy, right? And then HA proxy determines what's a primary or a standby, and then automatically, if application server connects to PG Bouncer and it wants to do a writes connection, right? You could go ahead and set the database alias in a way that it connects to the, for example, in your application logic, if you're able to distinguish between writes and reads. So what it means is you should be able to use different connection strings for writes and reads, which is the right way of building an application. So if that is happening, you would be able to go ahead and use PG Bouncer and say, okay, if it's reads, ask for a specific port, and if it's right, ask for specific port. And then HA proxy would automatically, based on that, should be able to go ahead and use the Perconi's REST API to go ahead and see, okay, what is a primary and what's a standby, right? And should be able to redirect. And we have, so in some time back, I was showing you in one of the slides, the blog post that we have done for high availability. So you would be able to see the HA proxy configuration file and how we have achieved this. And it's not the first time that we are kind of thinking of such a solution. This is already existing and it's being used by lots of customers already. And you could go ahead and deploy PMM as a monitoring tool and then a backup server. So all of these make a robust Postgres setup completely for free, either using Percona distribution for Postgres or even just community Postgres. So all these extensions are already part of Percona distribution for Postgres. We already discussed about it: PGDPack, PG Audit, PG Backrest, and Petroni, right? So, with that, I would like to conclude my session, and we will see you again at Percona Live online. And thank you.
Okay, Avi, thanks for taking the time to present with us today. If anyone has any questions for Avi, then please put them into the Slack chat. I think Avi will be hanging around for a bit, so he'll be more than happy to answer any of your questions. So Bronwyn here, I'm an event manager at Percona and I'm based in Dublin, Ireland. I'm here to introduce the next couple of speakers. So next up we have a change in speaker. So Jobin Augustine will be presenting instead of Sergey. Jobin, are you there?
Yes, yeah.
Okay, perfect. All right, so Jobin is a senior support engineer for Percona. He is based in India. And over to you, Jobin.
Thank you, Pranay. I'm sharing my screen.
Yes.
Are you able to see?
Yeah, we can see you.
Yeah, thank you for giving a good introduction. Yeah, I'm Jobin, and I'm working from India. And this presentation I originally proposed and prepared by Sergey, and we worked together. We were senior support engineers for Percona, supporting Postgres. Yeah, so since the lack of time, I'm directly jumping into the topic. So today's agenda is why we need a connection pooler at all. So what are the challenges we are facing if we don't have a connection pooler, and how these connection poolers are addressing that problems. And then we are going to look at some external connection poolers and their features and advantages. And finally, we are going to discuss some of the limitations of these external poolers. I think in the previous talk, Abby already mentioned about the importance of connection poolers. So this is a closer look. Okay, why we need a connection pooler. Okay, so the Postgres is a process-oriented database. So every client connection needs a dedicated server process. Okay, so when a user connects, there is a corresponding server session getting created. So the process working has a lot of overhead. It has memory allocation, and within the Postgres itself, it has to do the housekeeping, the cancel keys, and because the main server process need to track all the child process it creates and signal them properly. And then the child process need to complete the authentication, communicating with the client, the user credentials and things like that. So that there is a lot of overhead. And at the OS level, we have further overhead. But in new versions of Linux, this OS level overheads are really optimized by this copy on write and overcommits and things like that. A lot of optimization done on the OS level. Still, there is a lot of overhead. Yeah, and generally, more than a thread-based system, the process-based systems has more overhead in establishing a connection. And we see some of the things in the database. When a not so optimized server is used, we'll keep seeing a lot of new connections coming in and going when majority of the sessions are sitting idle. And yeah, so we see a lot of idle sessions hanging around in the server, eating up the memory and resources. Yeah. So the takeaway is that the process creation and removal has a lot of overhead in Postgres as well as in the OS. It consumes a lot of server resources. Okay, and the cost of idling connections. So there is, as I mentioned, there is a memory overhead and scheduling overhead and locking overhead. So if the logs are per process, so to check the log conditions, many of the semaphores need to be checked. So as the number of connection increases, all these overheads increases. So I'm not going to the details. So the how the semaphore allocation happens, the numbers are there on the screen. And another problem is if there is a spike in load, we need to accommodate that. So the DBAs tend to keep a higher limit for the connections. So because of that, for example, if the server is can handle 100 connections, DBA may keep it 1,000 connection to accommodate the spike. But those things will result in server abuse. Too many sessions will be coming and unnecessarily slowing down the servers. And we have seen a lot of outages, poor performance, and system unavailability. Okay, so we talked about the overhead. Now we are going to look at the one simple thing in the overhead, the impact of authentication. Okay, in Postgres, we can have a trusted authentication. For example, I can trust the connection coming from a particular IP. So there is the overhead is very less. So if you look at the number, this is taken from a very low end machine to show the impact. It's not a good server configuration. Yeah. So if the TPS is 130, and if you incorporate a password authentication, the password exchange happens. So the TPS drops to 95. And if the password authentication happens over a TLS, the secured connection, it's further drops to 72. So this is the connection establishment and disconnection overhead. But if the application is maintaining a persistent connection on the same machine where we got the 72 TPS, the TPS jumps to 658. So we can clearly see the impact of the connection and disconnection. Just one part of the problem, the authentication. Okay. Yeah, and to overcome all these things, the solution is use connection poolers, and always we recommended application side connection poolers if it is available and it can be properly configured, because that has a well integration with the ORM components, and but at the same time there is right sizing challenges, because there could be multiple servers connecting to same database, and in the connection poolers could be sitting in multiple places. So yeah, right sizing is a challenge. Yeah. Yeah, and if the application level connection pooler is not sufficient, that's a place where the external connection pooler comes in. Yeah. And external connection poolers are applicable if the connection poolers are not tunable. For example, if there is a third-party application where nothing can be modified, nothing can be adjusted in the built-in connection pooler, then yeah, we have to look into the external connection poolers. Okay, and what it really does, the connection pooler initialize a pool of connection at the startup of the application, or at the first connection comes. So if there is a 20 pool we specify, the 20 connections will be made to the database. And generally a user and database combination is defined as one pool. So any connection comes from the same user for the same database, a connection from the pool will be picked up and given. Yeah. The advantage is very less number of connections, very limited number of connections will be serving a large number of application connections. And another big advantage is connection request queuing. If there is a spike, all the connections won't hit the database straight away. Instead of that, we can limit, okay, the server can accommodate, say, 50 connections or 100 connections. Only 100 connections will be allowed, and rest of the connections will be queued in for the execution. So at the application side, there won't be any error like maximum connection exceeded or anything like that. The connection will be queued up. So it avoids the contention in the database. So overall, the functioning will be much smoother. Okay. And the external connection poolers can work as a routing mechanism too. If there is a server change, we can just manipulate that at the connection pooler level to route the connection, because it's a system in the middle which can route the connection. Yeah. And coming to the popular external connection poolers, the most famous one is the PG pool. It's more than a connection. It has the connection pooling capability, and like in the previous talk, Avi mentioned, it has the connection routing. It has high availability features, and recently it acquired this quorum and consensus mechanism for HA. And it can avoid single point of failure by adding multiple pools, and it has a built-in watchdog mechanism and VIP failover mechanism, and there are a lot features. I'm not going to the details, but at the same time, with all these features, it is considered as heavy, and in our many of the performance testings, it shows that extra overhead of having all the features. Yeah. People look for something very lightweight, something can sit in between. As I mentioned, it has high complexity and high overhead. So there comes the PG bouncer. It is lightweight and performant, and it has features like SSL support and PAM support, using which we can have LDAP authentication. And it's very popular. And it has the monitoring, because since it's popular, it has the community is more vibrant. And it is available from Postgres repositories, from multiple repositories. Most of the Postgres vendors, as Avi mentioned, has that PG bouncer in their own repositories. So it's widely available. And one of the limitations which a PG bouncer was like, it can occupy only one CPU core, and we are going to see the details in the coming slides. But recently, from Linux kernel version 3.9 onwards, same pod can be reused by multiple processors. So you can just search for that, and PG bouncer can utilize those features for scaling better. Yeah, but it's slightly complex. To overcome the limitations of the scalability of PG bouncer, a new project by Yandex is ODC. It's a multi-threaded worker. There are multiple worker threads in the background, and it has almost same feature as PG bouncer. In many places, we can call it as a drop-in replacement. But the other side is it's very new, like Sergey used to call it a black horse. Yeah. And there is the build is not widely available, and the ready-to-use builds are using OpenSSL 1.1, and you may face some problems if the OS is not compatible. So it's really new and cutting edge. There are a lot of things to be finished. Yeah. Yeah, and basically it addresses the limitations of PG bouncer. Okay, so we are going to see some of the performance numbers. As we can see, this is if the connection is persistent from the application side. The blue line shows we have higher performance. Because when we incorporate external connection pooler, it's an extra hop. One more, the connection comes to the connection pooler and goes to the Postgres. So if there is application level persistence, application level connection pooler, that performs much better. Okay, so this is the one thing we need to keep in mind. So it's not advertisement for any external connection poolers. So always application connection poolers works better. And when it comes to PG bouncer and the ODC, because we are just keeping this PG pools because it has a lot more functionality, and the performance is much more problematic, as Avi already mentioned in the last talk. Yeah, so we can see with SSL on. Sorry, without SSL, the connection overhead is less. So the PG bouncer can reach up to 6,000 levels of in a particular testing environment. But if there is overhead of SSL connection, the PG bouncer, the performance goes down very fast. So but obviously the ODC is slightly slower, but the performance is more consistent. So we tested with 256 connections. As we can see, after some time, if there is a SSL overhead, it matches the same performance as ODC. Okay, and what happens? So we saw this is a persistent connection. So that's not the case for external connection pooler. So now let's look at the cases where we need to really use a external connection pooler. The connections are coming and going. If there is no persistent connection from application, the performance is really poor. Okay, it drops, and clearly it is visible that the connection pooler advantages. And if you look at the right side of the slide, we can see that's where this ODC fixes some of the limitations of PG bouncer, because it has multiple processes, cores, threads, which can occupy multiple cores. It can better utilize high computational overhead, say SSL authentication. So ODC is going to give much better performance there. Okay, and so yeah, with the no pooler, so it's obvious. The Postgres with the no SSL always performs better. And with the PG bouncer, like we already saw this as a PG bouncer, if there is a lot of authentication overhead happens, the performance drops heavily. But in ODC, the drop is not to that extent. It scales better. It scales better. Okay, so the takeaway is that the application level connection poolers are much better if it can maintain persistent connections, but external connection poolers can be utilized whenever it is really required, and it gives good performance improvement. And we are coming to the limitations. So everything is not green. We need to understand some of the limitations. One is security and auditing, monitoring, and troubleshooting challenges. So when we look at the client address in the server logs, since this is the external connection pooler is a man in middle, all the connections will be coming from this external connection pooler. So we don't have a client address properly recorded. So it affects the auditing and even security part. If somebody gets into if the middle thing is get hacked, that's already it's a man in middle. Yeah, and the monitoring, we don't know from the connection is coming, and the troubleshooting is again big problem. Okay, so all this the server side traceability of the connections will be heavily affected. So that's one major limitations of external connection poolers. And from the functionality point of view, these are major challenges, because the same connections will be reused again and again. So we cannot have a prepared statement. Say a connection comes, and if it prepares a statement, and if it releases the connection back to the pool, and some other connection takes it, or this connection gets another connection from the pool, prepared statements won't work. So prepared statement won't be available, and temporary tables. So that is again a challenge, because temporary tables in Postgres are session specific. Yeah. So these are functionality level limitations of external connection poolers. Yeah. And performance and stability challenges. So if there is already a connection pooler which already maintains persistent, trying to maintain a persistent connection, many times we keep seeing in client cases where people keep connection pooler over another pooler. So it adds a lot of overhead and without giving any benefit. So the overhead of two poolers, without knowing that there is a pooler in the application side, use it only when required, and just keep assessing whether it is really required. There is overhead in getting the connection from the pool and releasing it back, and there is, as I mentioned, it's a extra hop to the pool and then to the server. And obviously there could be other overheads, like we discussed. We cannot have a prepared statement, so all the prepared statements or anything which is done at the session level need to be discarded. So there is a deallocate of everything and release the connection back. So the connection poolers itself supports all these options. We just need to specify, but there is an overhead that we need to be aware. And unlike the PG pool, most of these connection poolers may become a single point of failure, because all the connections goes through that. If there is multiple applications connecting through same connection pooler, then that could become a single point of failure. Okay, so coming to the references, so we have a good number of references, and we have Percona blog where we discussed about the advantages of this connection pooler. Please refer to that for more details. Okay, thank you very much, and Percona Live, welcome.
Okay, Jobin, thank you very much for taking the time to present to us today. I know that we're a little bit early or ahead of schedule, but we have the next speaker here ready. So our next speaker is Ibrar Ahmed. He is a senior software architect at Percona, and he is based in Pakistan. Ibrar, are you there?
Yes, I'm here.
Okay, perfect. Well, if you want to go ahead and share your screen, and we'll get started.
Yes. Let me share my screen.
You may have to go into present mode. Yeah, there you go.
Sorry. Yes. Present mode. Yes. Is it okay?
Yeah, that's perfect.
Okay, let me. Yes. So we have 2 or 3 minutes.
Yeah, you can go ahead and get started. I know we're a little bit early. But yeah, if you want to go ahead, and then if there's some time at the end, perhaps you could answer some questions, or if there's any other questions that come in, we might have a bit of time after this.
Okay, thank you. So welcome everybody. So my name is Ibrar Ahmed, and I am here in a senior database architect at Percona. So today's topic is joining heterogeneous databases is a reality, not a myth. So I will start presenting my presentation here. So why Actually, the problem is when you want to access data from multiple sources, then the question arises, why you need that? Because the problem is when there is a huge database cluster where you have a multiple databases, then you require a system where you want to collect data from different data sources. So how you can do that? This is a simple statement. You can see in the screen that I have MySQL, PostgreSQL, Hadoop, MongoDB, ClickHouse, Hive, and a simple file system. These are multiple data sources, and you want to access the data from all of these database engines. So what will you do? A simple query, select static from multiple database engine and generate results. It won't work because it's not a language. So you require some kind of a system where you can pull data from PostgreSQL, MySQL, Hadoop, MongoDB, Oracle, Hive, ClickHouse. So you require a system. So that's the question I want to answer here in my presentation. So whenever you build an application, you see you have an application architecture where you have an user application and you have on a databases. So in this diagram, you can see you have a user application on very left side of the screen. And on your right side of your screen, you can see a different databases, MySQL, PostgreSQL, Mongo, and etc. So when you're building your application, when you're writing your application, you can see here is the box where you need to write a application along with a module of MySQL, where you use libmysql client library to connect to MySQL. So in that application, you need to write a MySQL module, which is using libmysql client to access from MySQL. Secondly, if you want to access your PostgreSQL data, then you need to develop a PostgreSQL module. Then you need a libpq library, and you need a libpq library to access PostgreSQL. Similarly, for MongoDB, and you need a libmongo C or any C library to access to the MongoDB. So if you have some Spark, Hive, and Hadoop, which usually access using JDBC, so you require a JDBC module. So you require expertise to write a JDBC code to access Spark, Hive, and Hadoop. So for ClickHouse, you need ODBC. So when you are developing an application, you require expertise to write a code, expertise to see in Java, and you need expertise to use the libmysql client library, libpq library, libmongo C library, JDBC, ODBC. That means a lot of libraries you required in your system first, and you need a lot of expertise to use that library. And then when you are getting data from these databases, from using these libraries, then you need to join them within your application. For example, you go to the MySQL library and got the data from MySQL, from PostgreSQL, from Mongo, and you want to join that data. So that you need to do that in your application. So that is the pain. Because if you want to filter your data based on some condition, then you have to pull all the data from MySQL, from PostgreSQL, from Mongo, and filter out your data within your application. That's another problem, because you don't require that amount of data you are pulling from the databases. So this is a question I'm not answering. I will answer. This is the answer I'm going to give you. SQL Med, it's a SQL to manage external data. It's a standard. It's an ISO standard. And PostgreSQL start implementing that in core in PostgreSQL version 9.1. So it required some kind of a mechanism, a machinery within the core PostgreSQL system, where the other application developer can develop foreign data wrapper for that database. So main thing is the core machinery required in the database, and PostgreSQL start implementing that SQL med in PostgreSQL version 9.1. And along with that, they have also developed a PostgreSQL foreign data wrapper for like PostgreSQL database, and you want to access another PostgreSQL, so you want to access an external PostgreSQL within the PostgreSQL, then you require foreign data wrapper. So they develop PostgreSQL foreign data wrapper, and they give an API, a callback system to the user, so they can implement their own foreign data wrappers. So here is the link. If you can go there, you can see dozens of foreign data wrapper, even many more foreign data wrapper you can see for almost every database. You can see a foreign data wrapper for that. What does that mean? That means if you have a foreign data wrapper for MySQL, that means you can access MySQL data, external MySQL database within the PostgreSQL using that MySQL foreign data wrapper. So if you want to access an external database, then you require a foreign data wrapper of that database within the PostgreSQL. So then you can access that. So how? I will let you know how. So here is an application architecture too. You can see it's I just change the position of some module and eliminate some module from it. So why? If you see here, you have a user application, and in that user application, you require only a PostgreSQL module. Keep in mind, you want to access MySQL, PostgreSQL, MongoDB, Spark, Hadoop, Hive, and ClickHouse, but you only require a PostgreSQL module. You don't require any MongoDB, Spark, and Hive module. In previous architecture, you required that, but now you don't require any of the module of other database. You require only PostgreSQL module. So in that PostgreSQL module, you only connect to PostgreSQL using libpq or any JDBC, ODBC. You just only need to connect to PostgreSQL. So in first phase, you don't need expertise to implement MongoDB module, Spark module, JDBC module. You don't need an expertise of that. Secondly, you don't need to maintain these libraries within your application. I will one. That's an interesting one. So you connect PostgreSQL, and PostgreSQL you need to install foreign data wrapper, which is usually used as the FDW within the PostgreSQL. You need to install that. You need to install the extension of foreign data wrapper within the PostgreSQL. So where will you get these extensions? So the first one is the PostgreSQL FDW. So PostgreSQL core already have that extension. So you don't need to install that extension. So it's already there in PostgreSQL. So for MySQL, there is a GitHub page. You can go there and you can download MySQL FDW. Even you can, its RPMs or Debian packages are also available for that. So MongoDB FDW, it's already available. HDFS FDW, these are all available on GitHub pages. So you can go, you can search that. You can install using PG extensions also. So now you are only connecting to PostgreSQL, and PostgreSQL foreign data wrapper will connect on behalf of you to MySQL, to PostgreSQL, to MongoDB, to Spark, to Hadoop, to Hive, and ClickHouse. And you are not requiring any kind of a library to connect to these databases. These foreign data wrappers will connect and get the data for you from these databases. You only need a syntax of PostgreSQL, a PostgreSQL library, and PostgreSQL module. That's it. And these databases will collect data for these foreign data wrappers will collect data from these DBMS engines for you. And the last one, which is a benefit, that benefit is it will filter out the within the PostgreSQL and join data within the PostgreSQL and give you final result to your application. In your application, you don't need PostgreSQL will do that, and client will get the final result of the data. So that's the major benefit of that. So the next one. So if you are not able to get in my point here, so I have an example here. Simplify the whole concept of foreign data wrapper. Like you have a PostgreSQL database where you are saving states of United States, and you have a MySQL database where you are saving the countries or country names. So third one is where you are storing the flight information. It's a ClickHouse database. It's another column store. So you have multiple tables. Like first table is PGTBL states. It's PostgreSQL table. And MySQL has a MySQL table continents, MySQL table countries, and ClickHouse table on time. So these tables are on different databases. So if you keep in mind on the first architecture, then you have to connect to PostgreSQL and get the data from states table. And you have to connect to MySQL to get the data from continents and countries table, similarly with the ClickHouse. So we will do that using foreign data wrapper. So first, you need to install create an extension of MySQL. So keep in mind that MySQL FTW, you need to download that libraries and install that. Then you need to create that extension. So the first statement is create extension MySQL DB _ FTW. If it's not installed on your system, you will get that it's control file not found. A file not found control is a MySQL FTW .control file not found error message. You will get that. That's mean it's this extension is not installed. So you install the extension. So now you need to create a server. So what does that mean, server? Server means you have to specify the location where your MySQL server is. So you are within the PostgreSQL and you are telling PostgreSQL server that this 127.0.0 host and port 3306 is my MySQL server address. That means whenever you access MySQL _SVR, this one, it means it's a MySQL server because it's the MySQL FTW and it is running on 127.0.0.1 and port number 306. So you here, it's not necessarily 3306, or it can be any, but MySQL should be running on that port too, obviously. Then you need to create a mapping. Why mapping? Mapping means that when you access PostgreSQL and want to access MySQL, so there should be some kind of a mapping because you don't need to provide a MySQL password again and again. So you are creating a mapping that whenever you access PostgreSQL using user PostgreSQL, it will connect to MySQL server using this username, MySQL user, and MySQL password. That means whenever you connect to your PostgreSQL server using PostgreSQL, Postgres user, it will connect to MySQL server using MySQL user and MySQL password. You can specify any. If you create a separate mapping, like create user mapping for any other user like foo, server MySQL server, option username X, password Y. That means whenever you're accessing Postgres using user foo, it will connect MySQL using username A, X, and Y, password Y. So it's a mapping between PostgreSQL user and MySQL user. So after that, and keep in mind, without creating a server and mapping, you cannot access tables. So now you are creating a foreign table. So it's kind of you are creating a some kind of a mapping. It's not a physical table created by using this statement. You know that when you create table MySQL, any table, then it will create a table physically on your disk where you are specifying. But when you specify foreign, that means it will create only the metadata of that. It will not reserve any space for that. And where it will point to the server, MySQL server, and option is DB name DB. So what does that mean? It means we have created a table, MySQL table continents, which has 2 columns, code and name, and it is pointing to the server MySQL _ SVR within the database name DB of MySQL. This DB name DB is a MySQL database. It's not PostgreSQL database. That means we created a mapping of not mapping. You can metadata of a table with 2 columns and pointing that to storage to MySQL server, which is installed, which is running on 127.0.0.1 port number 3306 and within the database DB. And similarly, we have created another table and its name in MySQL table countries. So we have created a 2 table metadata which are pointing to the MySQL tables within the database DB. So now we also need to access the ClickHouse. So for ClickHouse, we are also create extension ClickHouse DB _ FTW. So create extension ClickHouse FTW, ClickHouse DB _ FTW. It will create an extension. So similarly, create server will create a server of foreign data wrapper ClickHouse FTW, and it has a slightly different options because we are not providing the IP address here. You can provide the IP address and other thing, but here we can specify the database name also, because every foreign data wrapper has its own options. It's dependent on the who implement this foreign data wrapper. So the ClickHouse required a DB name in server name, and it also required a ODBC driver. So we need to provide the ODBC driver path for that. Otherwise, it will use a default ODBC driver if it's installed on the default location. If it's not installed on a default location, then it will pick using this one. Otherwise, third option, it will throw an error that ODBC is not installed. So here, we also created a mapping for that. So that means whenever we connect to the PostgreSQL whenever we connect to PostgreSQL using Postgres user, then it will connect to ClickHouse server using ClickHouse user and ClickHouse password. You can specify anything. I just mentioned ClickHouse user. That means you can specify X, Y, or any password. It's up to you. It's just an example. So here I have created another table. And at this time, if you see, I have specified foreign data wrapper, foreign server, which is ClickHouse server. That means ClickHouse TBL on time, this table points to the ClickHouse server. And interestingly, I have changed something here. Previously, I have not specified the table name. So if you not specify the table name, then this name ClickHouse TBL on time should exist remotely on ClickHouse. If you specify the name, table name, that means ClickHouse table name on time map to the ClickHouse server's on time table. So I have just changed it to give you the idea that if you specify the table name, then it will map to that table. If you don't provide any table name here, then the same name will be used on the remote server. And it should exist on remote system, both the cases. So here is an example. So I am selecting data, select static from MySQL table continents. So from where this data comes from. Similarly, select code, name, continent code from MySQL countries limit 7. So just I'm selecting the 7 data. So from where this data is coming? So keep in mind, we are within the PostgreSQL. You can see it's a PostgreSQL. And we are querying a table, MySQL table. So this is the foreign table. And this will go to the foreign data wrapper and get the data from MySQL database and show it to you like a PostgreSQL table. So there is no difference between Postgres and MySQL table. So it's seamless. You are just selecting from table, but it's not a PostgreSQL table, actual PostgreSQL table. It's a foreign table. And the data exists in MySQL. It's not PostgreSQL data. And it's remotely stored on MySQL on both the table. So it's getting data from. So what I have told you, you wrote that query. This query has a syntax of PostgreSQL. So I have used syntax of PostgreSQL. And you are getting the data in PostgreSQL format. Data actually exists in MySQL. So that's the beauty of foreign data. If you are doing that in your application, then you have to connect to MySQL and you have to use the MySQL syntax to collect data, and it will give you the data in MySQL format. Then you have to convert into PostgreSQL format and something like that. That's a big thing. And this foreign data wrapper is doing that for you. Everything is done by foreign data wrapper. So this similarly, where data comes from. So here I'm selecting data, select countries, country name, and different, and I'm just applying some condition. So you are getting some data. So this condition is applied on remote system, not local system. Like if you are doing that in your application and you have to do that yourself, then you have to join, you have to mix two tables within your code. But when you are writing this query, you are sending this query to MySQL. You are using the PostgreSQL syntax. This is a PostgreSQL syntax query. And foreign data wrapper will convert that query into MySQL syntax and give back to you the result, a filtered, joined result in PostgreSQL format. So ClickHouse. So I have given you some complex example here. So now we are selecting something from ClickHouse table. Select a alias, so year, and dividing two columns as value from a subquery where count and as C1 from ClickHouse on time table, and then inner join and select another subselect, and then adding some condition on that, and then joining on. So it's a complex query. So we are sending this query to ClickHouse and ask ClickHouse to evaluate that query and give me the result of only. It has some kind of a trick here. So I will let you know in next slides. So that where you have to send the whole query, where you're not sending the whole query. There's some trick here. So I will let you know what's the trick here. So just keep in mind that we are sending this query for now and getting the result. So here, this query will join PostgreSQL, a local data, with MySQL remote data and ClickHouse remote data. That's the beauty, that you are writing a query in PostgreSQL format, and which will join the 3 tables, one local PostgreSQL table, one remote MySQL table, and one remote ClickHouse table, and you are getting the final result in PostgreSQL format. So you can see left join within the MySQL and PostgreSQL table, and then ClickHouse table. So you are getting the result here. So if I explain that query, so then what will you get? Most of the people, you know that what is the explain. So if you don't know about the explain, that it's just a query plan, just a query plan. So every language, every DBMS has a system to show the query plan. So here is the query plan. You can see in the query plan, the query is divided into multiple sub-queries, multiple query. Like the first query, we are reading from the bottom of that query. So we are sending a query to to ClickHouse. You can see the table on time. On time is a ClickHouse. So you can see the foreign data wrapper on time. Yeah, this one, the ClickHouse table on time. So we are sending this query to ClickHouse, and we are sending this query to MySQL. And this we are joining this query join filter, and we are using the hash condition and getting the final result. So what I have known, so what we can send to the remote system and what we cannot send to the remote system. So it's called a push down. Like if I have a condition and have an operator like is equal to something like operator. So we are sending this operator and function to the remote system to execute that function on the remote system. Secondly, predicates, a qualification, push down. That means if we have some kind of a where condition, so we are not evaluating the where condition locally. That's the benefit. We are sending this where condition to the remote system. So we are getting the final result. We are not getting all the result and filter that result in our system. We are sending the where class to the remote system. So we are getting the less data. So similarly, aggregate push down. So we are sending an aggregate function to remote system to get the result. So that means we are not collecting all the data on our system and then aggregate that data. We are just sending the aggregate to the remote system, function to the system, and getting the final result. And again, the join push down. You have a 2 remote table and you want to have a query and joining these tables remotely. That's called a join push down. We are not collecting data of each table and joining in PostgreSQL. We're sending that to the remote system to join data for us. Here is an example. Join push down. You can see a remote query here. Select this, and left join, and you can see this join is executing remotely. Sorry. So here example of aggregate push down. So here explain verbal select count static from PostgreSQL. PostgreSQL is a foreign data wrapper here. So external table. So you can see in a remote query, we are sending count static from remote table. That means our remote system will calculate the rows and give me the final result of one value. But if you see in the second box, in the bottom, we are selecting count static from the MySQL, and MySQL does not have MySQL foreign data wrapper does not have that capability. That's called aggregate push down. So in that case, we are selecting all the rows from MySQL and counting that. That's problem, and this is the problem in MySQL foreign data wrapper. Anybody can jump in and implement that aggregate push down in MySQL. So we have, I think we have 5 minutes left. So PostgreSQL query. This is the flow. We have a client. We are sending the query to PostgreSQL, and PostgreSQL convert that query into MySQL query, and the FTW connect to MySQL and send that MySQL query to MySQL. And then MySQL get the results, give the result to MySQL FTW, and MySQL FTW convert that result into PostgreSQL tuple format, and finally we are getting the client. So client is, if you see 1 and 8, client is sending PostgreSQL query and getting 8 result tuple in PostgreSQL format. So in between, all the steps has been done by FTW. So do we really need to do this step number 3 again and again? Connect, query, disconnect, like 3 and 6? No. There is a concept that we are just sending a query, first connecting to the MySQL, and then if it's failed, then we connect that. That means we are retaining the connection for next query. So initially there is no connection, it will connect to MySQL and it will not disconnect it. So if you send the next query, it will use the same connection. So it's called a connection pooling within the FTW. And it depends on the FTW, it has a pooler or not. So if it doesn't have, mostly the foreign data wrapper has that feature. So there is, I have not discussed this, which is called the DML support. Most of the foreign data wrapper has a DML support where you can insert the data in the table, because you have now table, the same table. So you can now insert that table, delete from that table, update to that table, like normal table. So you can do that. And these foreign data wrapper has that capabilities. So if you have any questions, and just ask the question. And the last thing, the Percona Live online will be on 20 or 21 October 2020, and it will be live online. So you have to be registered there. And thank you for this. If you have any question, so I'm waiting for that.
Okay, Ibar, thank you for sharing your talk with us today. The next speaker that we have is Robert Bernier. Robert is a Postgres consultant and based in the US. Robert, are you there?
Yes, I am.
Okay, perfect. Let me just stop sharing my screen and I'll hand it over to you.
All right. And let me set myself up on my end. Camera. Yes, I assume you can see me?
We can see you, yeah.
All right. So from Seattle, good morning. It's still so early that I haven't had my second coffee yet. So I'm sort of halfway between strung and overstrung. Before we start, a little bit of housekeeping. Everybody that's listening, everybody that's watching, welcome. And I am the Postgres consultant out of the professional services group. And in these days of COVID, I know a lot of people are suffering and having difficulties, and I wish everybody well. Interesting thing about open source. When things are good, you're busy. When things are bad, you're even busier. And things are very, very busy here at Percona. So much so that we're looking for another Postgres consultant. So if you're nice and you'd like to relieve some of my work pressure, please reach out to us. Tell us about yourself. And continuing from there, I am now going to share my screen and do my little talk. Let's see if I've got this right. And there we go. Can you see my slide?
Not yet.
Not yet. Okay, let's try share screen. Ooh. That's interesting. I'm not getting a response on my system. Let's see if I can do this. Nope. For some reason, I am not able to share my screen.
Okay. Do you want me to share my screen and I'll flick through the slides?
Let's see. Yeah, let's see. Yeah, give it a try. Let's do it that way. Hold on here. Let's see. Recording live. Yeah, bring up your slides. We'll do it that way.
Just one moment. Sorry, just bear with me now. I just have to get them in here.
We have our first snap.
Okay, so let me go and share my screen. Oh, sorry, that's the wrong one as well. Okay, just give me 1 second and I'll open it up here. Wow, technology doing it live, eh? Okay, can you see my screen now?
Yes, I can.
Okay.
All right. Right, next slide, please. And next slide. Good, thank you. Nope, nope, back, please.
Oh, sorry.
There we go. All right. So we have about 30 minutes. What I'm trying to do is to tell you about a real case study that took place some time ago. And this talk was originally based on 3 hours, full of details, full of conversation, a lot of back and forth between the people who were listening and I was speaking. So it's a bit of a challenge to compress it down. If you are involved in doing migrations, please take note because this is real stuff. This is the real technical information. It's a high overview on how to do it. Next slide, please. So the thing about moving data, migrating from SQL Server over to Postgres, let's go through the simplified approach. First thing you need to recognize is the foreign data wrapper. In this particular case, there's a foreign data wrapper called TDS_foreign data wrapper. You identify the foreign tables, the connection information that you're going to do. You create your foreign tables, and you copy the data from the foreign tables into Postgres. That's the simple high overview step. Lots of details in between. Migration isn't complicated. What it is, it's a lot of steps of little things. It's tracking all these little activities that can trip somebody up. Next slide, please. So in this particular case, we were working with anything with the Postgres version 9.6 and greater. So we had to design our target database on Postgres. What's it going to look like? What do you have to do to make it work so that it's going to be able to migrate successfully? SQL Server works on the concept of schemas. Postgres works on the concept of schemas. So we try to match them in as well. We also need additional information. You notice on the slide here, I have on the 4th point, identify system catalogs and tables of interest. It's not just the data. It's the data about the data. We need the definitions. How are the tables constructed? What is the order of the columns? Where are the foreign keys? What are the constraints? Where are the views? What are the codes and the instructions inside the sprocs and the function calls? So we're dealing with functions, tables, constraints, primary key, foreign key, check constraints, views, triggers. Then after you identify all these, then you go into your function, your sprocs. You install, once you've identified all these issues, then you're ready to install your foreign data wrapper. Then from there, get your connection info, you create your foreign table, you populate the table, you apply the constraints, you process the triggers, then you process the views. Now, populating the table is actually, it seems to be a straightforward thing. But in our particular case, we had an issue. We actually had to deal with encoding issues. Microsoft has their own standard of encoding, and there were coding corruptions. So we had to figure out how to deal with that. There were pieces of data that weren't working out. The constraints. The constraints is an acid test. When you apply the constraints correctly after the data is in place, if the data is wrong, you want to know. The constraints, by applying it, you catch it. The triggers themselves, they're standard operation. You have a table, you want post-processing, you want updates, you want special information or processes to be decided by virtue of the triggers. When you're going from SQL Server over to Postgres, let's acknowledge the obvious. The code isn't going to be the same. So what do? You disable the triggers. You create a shell of the triggers, and at a later point, then you address. What you want to do is just define the steps. Are the triggers in place? Will the triggers fire for certain operations? That's what you want to test out. The views themselves, the environment, the client that I'd worked with had a SQL Server system that had been in for many years and had been taken care of by many people. Now, there's two ways of using a database with intelligence when it comes to report generation. One, the dominant popular way right now is where you have application servers that take the raw data, they munge it, they create the reports, and they present it. But then there's the traditional way, the way that has been used historically in SQL Server, in Oracle, not so much in the open source databases, because the modern way, the more advanced ways are always being adapted first in the open source approach. So what we had were views that would actually generate the reports. You just read the views and out come the reports. But the challenge was over time, these views didn't get dropped, they didn't get updated, they created new ones. So you would have the first generation of views would be based on tables, then the second generation of tables of views would be based on tables and views. And then over time, these views would become more complicated, more convoluted. So how do you migrate views over from SQL Server over to Postgres with that kind of a history? The solution actually is pretty straightforward. You create the views, you get the codes, you define them, and then you just run the instruction in Postgres. When it fails, you have a dependency issue. Fine. Run the script, you cycle it, then you run it again. If you've done everything right, over time, every time you cycle over and over, creating and processing the views, the number of views that are left out are going to be smaller and smaller and smaller. And finally, you'll either, under ideal conditions, have no more views, or you're going to have a couple, which means there's something wrong. There's something inside the definition that you need to look at. Next slide, please.
I've given you remote control, so you should be able to click yourself to the next slide.
Okay. How do I do that? How do I do remote control here?
There you go.
That one?
Yeah.
Cool. I learned a new thing. Okay. As the title says, here's the secret sauce. I'm giving credit where credit is due. Postgres has always, in principle, always been compliant ISO ANSI standard. Microsoft also has been doing it. Without Microsoft being ISO compliant, ANSI compliant, we wouldn't have been able to do it as easily and as simply as we could. The reason is the information schema. Postgres has, by addition, PG catalog schemas, the metadata, the data describing the data. Well, in SQL Server, you have sys schemas that have the same information, but the ANSI standard is the information schema, and the information schema is consistent between Postgres and SQL Server. You can actually look at the table definitions in an information schema in Postgres, and you will find the same definitions, the same description of the columns. They're located in the same order. Now, there are differences, and we're going to go through how to deal with that. When you look at the importation of functions and sprocs, understand that when we did the import, that has to be considered a separate exercise. It's tedious work. What you want to do is get the skeleton of the function and the sprocs over, just so that it can compile, just so that it can be put into Postgres. Then the actual exercise of refactoring it, you'll be in a position to do that. In our case, we had two teams. One, perform the migration. Two, refactor the functions. When you do this, in our particular environment, we didn't use a Windows environment. We went straight to Linux. We had Linux workstations because we wanted conformity as closely as possible to what the server was going to be. So when you do it, you can generate the system and you create an environment, a build environment that can cycle, break up these steps into modules, and then you're going to find out there's a lot of mistakes, a lot of things that are going wrong. So you just make your little changes over and over and over. The last step, a very important step, this is your validation. Get yourself a command line interface for your for your SQL Server. And in this particular case, Microsoft was very good. We had recently become aware of that when they put in the Azure cloud for a SQL Server, they made command line clients, and those clients fitted nicely on our Linux box. So we were able to test, validate, even double check on the constructions of the various tables and check out our connectivity. And let's go to the next slide. Did I do that? No, I made that smaller, wrong one. Oh, here we go. There we go. Being a Postgres DBA, I did all my reference information, all my decision making using the Postgres references. It is bar none the best referencing for any database system out there. When you look at the system catalogs on the left panel, the equivalent is on the information schema on the right panel. The right panel, that is what SQL Server also honors. They will have the same types of tables with the same kind of information. Keep in mind, it isn't all the time one-to-one. When I was doing the migration, there were discrepancies. Using the command line interface, I was able to query SQL Server and find out where those discrepancies were. This is the page. Again, it's a bit dated. It's probably changed since then. Again, because we were on a Linux environment, it made it especially easy. Just downloaded it and installed it, tested the connection, made sure that we were able to do everything properly. Okay, so this is the complicated part. You're going to break down and you're going to organize your Postgres database. You need to break down into various schemas. Now, public default, which you always find in Postgres, that was going to be the first schema where anything ad hoc tables, functions, etc. we're going to go. DBO schema. This is just a copy. It's a default of the SQL Server. It's for consistency, prevent confusions. And now we've got these other schemas. These are going to be information schemas, and they're going to be foreign tables. There's two classes of these schemas. One is you're getting foreign tables in, and the foreign tables are going to be two types. You're going to get foreign tables of information schema, the actual metadata, and then there's the actual tables from the SQL Server that you want to migrate. In this example, you can see the organization on the left panel, MMSQL, information schema, MMSQL. What we want to do is when we do the migration, when we do the refactoring, we want to offload all the necessary metadata, all the necessary information, copy it into Postgres, get it there and detach it from the SQL Server. Make it simple. We want to get away from the connectivity with SQL Server because it adds another level of complexity. So you copy, using the foreign tables, you copy the metadata and you copy the imported tables. That's what run was. Run information schema and run. Finally, the last schema was views. And that was regenerating the views. And that was the iterative process of building and refactoring the views in real time. Once you've got the copies of the metadata, once you've got the actual data in place, you can forget about SQL Server. From here on in, you're just working in the Postgres environment and you can work in a Linux format. Oops, let's see. Okay, so the next step is the obvious. Let's install Postgres. So in this particular case, it was a version of Ubuntu. We installed the keys. Now, all this documentation is already listed in the Postgres download page. We're just reiterating it. And look at the bottom line. We want the server development libraries because we're going to compile an extension. The SQL Server extension doesn't come, at the time that this was done, it didn't come as a pre-made extension for a particular version of Postgres. So it had to be compiled. When we created the environment, now a lot of people are used to the idea of using virtual machines. In this particular case, I wanted to test the network environment, so I used Linux containers. By creating a container of a particular version of Ubuntu, I was able to replicate and put everything that I needed. Okay, so here's the information about creating the foreign data wrapper. Again, this information may be dated, you may have to update it. What I like about the Ubuntu distribution, it's a Debian derivative. All the libraries that you need, they're going to be there. Sometimes the other distributions, they don't have it there. It doesn't matter if your final target is Red Hat or if it's something else or if it's CentOS. By putting it on Ubuntu, you make it easier for yourself to get the libraries prepared. Transferring it over is pretty mechanical once you've already got a working version of Postgres. So as you can see, these instructions here, again, they're published. All you need to do is to locate the GitHub, and you'll find the same instructions, up to date, of course, and you'll be able to replicate and create the extension. So we need to test our connectivity. We've got the extension in place. We check it out. Of course, what's not written here on the slides is using the SQL Server command line interface. We use that to verify our ports, our usernames, our databases, our passwords. Once we've confirmed it, we replicate it here in the foreign tables. Again, you can see here, here's our foreign, the implementation of importing foreign tables, which is really nice when you do a schema because it's a one-off. It was very useful in our case because we had several hundred relations. I had just short of 100 tables and several hundred views. Doing this replication, this manner of importing the foreign tables made it a lot easier. Okay, now issues. So let's go to the point where we've installed. We've gotten the foreign tables. We are importing the data. We're copying the data into the tables. We've succeeded. So what about everything else? Data types, operators, function overloadings. When you write it out, again, you're now going to create this Linux development lifecycle environment. So you need an environment that's going to be able to be easy to read, easy to understand. You're going to deal with check constraints. When you create function calls, the practice that I've always used is use the in and out arguments. It's clear, especially it's important because I wasn't familiar with SQL Server as well as I am with Postgres. So you want things as clear as possible. Explicitly say, where's your in arguments? Where's your out arguments? Because when in doubt, you can ask somebody else and they read your code and they understand it better. One of the things to keep in mind, the functionality of the code, the instructions, they're not going to be one-to-one mapping. Don't worry about it. Comment them out. Put them in as a reference. You don't want them active. All you want is the shell. Okay, so Postgres is amazingly flexible. It can do operator overloading. It can do function overloading. It can mimic a database system. The question is, do you want to do that? In order to do the migration, do you want to save yourself time by just creating the same symbols and operators that SQL Server uses? Or do you want to take the time to refactor the code? That's a judgment call. It is a judgment call. You're going to have to decide on your own. The way we did it was we broke it up into modules and activities. So we actually did do an overload, but in the long term, we removed the SQL Server behavior that we were emulating with the operator overload in order to have a more consistent Postgres interface. Keep in mind, once the system is up and alive, you may walk away from it. There may be other people that's going to maintain it. Don't presume that they're going to have the same knowledge set as you. So converting, editing, overloading, there's all sorts of tricks. This is Linuxy stuff. Sed, grep, awk. When I was working with the views, the function calls, the regex matches, those were great functions. They allowed me to change things. The code that was being migrated was actually pretty consistent. So it was possible to do a pretty good job of changing things out. If you're really fancy, if you're a Linux guru, you could even go old school and use scanners, Lex, Flex, Yak, Bison, etc., etc. So here we go. In the particulars, what are you looking at when you have to deal with conversion considerations? Check constraints, check them out. Queries. Sometimes the queries are going to be written a little differently. That's what you're going to have to reconvert, massage. You're going to find the bulk of your work in doing conversions, this first pass of migration, getting it on Postgres, just getting it there successfully, is going to be dealing with the views. In terms of functions, you can see the examples: date part, date add, date diff, function overload. We had to emulate the functions. I didn't want to rewrite it inside the functions. There were several hundred of them in these views and the function calls. So I just created the functions. It made it easier to see what was happening. Is null versus coalesce. That's a big issue here in SQL Server because it has intrinsically different behavior. Is null on SQL Server is different than is null on Postgres, vice versa with coalesce. Operators, take a look at the example. The double pipe for concatenation of Postgres, that's not what's used in SQL Server. It uses the plus. Money conversions, Postgres, SQL Server. Again, there were these little issues. Triggers, again, they were other issues, more complicated. This is where we shorten things up. What I'm doing here is in the 3-hour presentation, we went through the actual code, and it was actually really quite fun looking at the instructions. It was all written in Bash, but we're just going to look at the overview of the scripts themselves because, again, we are reiterating the steps. So the first thing was, okay, create the foreign tables. Remember, break all this down into modules. It's just easier to figure things out. Watch out for the casting data types. Watch out for SQL Server's column and table mixed case names. When creating the foreign tables, they were mixed, but when they were copied over as tables in Postgres, when the data was copied, the tables were explicitly lowercase to follow normal standard Postgres convention. Now, it is true that when you work from GUI clients interacting with Postgres, you can do mixed case, but in our case, we just preferred lowercase. It just made things for us, because we were working on the command line, a lot easier, more straightforward. The next script, populate the tables. Now, the population, actually, it was remarkably slow sometimes. It's the nature of the beast. It's one of the reasons why we wanted to disconnect from SQL Server as quickly as possible. The foreign data wrapper took its time to translate and populate the tables. They did populate. It was like several hundred gigabytes large, the entire data set. It took time. Constraints. This was a fun part. We had to go into the meta tables in SQL Server to identify all the constraints. We needed to compose the queries. This particular script that we're reading, that I'm using as reference, actually queried the constraints in order and rebuilt them and reconstituted them on the Postgres side. It listed all the tables, it identified the columns, the table constraints. What we've got here are the actual tables, the meta tables that we need. So as I said at the beginning, we copied everything. The foreign tables, in this case, we copied the meta table, the information schema from SQL Server over to Postgres, and then we played with the data. We were able to take the information gleaned by copying the tables over and creating proper function migrations to be able to reconstitute and recreate it. This took time. It was actually quite complicated and detailed, and it was fun. There's a little comment here on the screen. You see where it says beware of MS catalogs, 2 kilobytes? There was one view that we had that was about 6 or 7 kilobytes large. Now in Postgres, that was no problem for the information schema view, but there was actually a 2 kilobyte limit. It truncated the view in the information schema in SQL Server. I was forced to go to the sys objects and read the information from there and copy it over. Beware, and remember that command line interface going to SQL Server, it helped. It helps a lot. Populating the tables, the information schema. Once we have the tables, the schema information, we copy it over, get it over so we can work with it. Now we're ready to add primary keys, add foreign keys, and we're reading the metadata and we're applying them. Primary keys first, then we did the foreign keys. Everything works, it just finishes. When you have inconsistencies, that's when you find out. Not just with your constraints, but data corruption issues. The trigger list. This is where we had to, I cheated. I went to Google. There was a nice old SQL Server copy and paste about how to get the triggers, and we were able to output it out. Don't be afraid to Google this stuff. As well, if you want, I can take the steps, reach out to us, and I'll see about getting copies of these shell scripts available to you. Lifecycle, add the views, regenerate, get problem views. Linux does standard error, standard output. Standard error was great. Anytime there was a screw up in the cycling, it just made a list and I reviewed it. I ran script 08A over and over again until I had a limited number of views left. And then from there, I examined what the nature of the errors were. There were many issues. It's the development environment that makes the difference. Get everything set up, get everything over from SQL Server, and you're good to go. And I thank you. And I think I made it in 3 minutes. So don't forget, we have October, we have our Percona Online. If you have questions, please put in the channel. And that's it for me.
Okay, Robert, thank you very much. All right, so next up we have Jobin again. Jobin, are you there?
Yeah. Let me
Okay,
share.
perfect.
I'm sharing my screen. Are you able to see?
Yeah, we can see your screen.
And thank you. I'm back again with a different topic. This time we are going to discuss about the commit synchronization in Postgres. Because very frequently we come across tuning this and convincing many of our customers to improve the performance. Yeah, so I thought of talking about this. And yeah, so overall, the presentation is all about the durability of asset rules and how Postgres is going to handle that. And today's the talk agenda is the big picture of entire DML operations. I'm not going to go in deep, only the peripheral things. And why the VAL. VAL stands for write ahead logging. And that's where the durability is assured. And what is VAL and what it is called, what is the VAL segment, and the VAL records types, and we are going to see some of the internals, how the system works. And finally, we are going to look at some of the parameters, tunings, and its implications. Okay, so let's get started. So the complete picture will be very complex for a DML operation. The blocks need to be fetched from the disk to the memory, and if required, new pages will be added, and the VAL records will be prepared, and it will be there in the VAL buffer, of course. And finally, it will be flushed to the disk. The VAL will be written and commit and acknowledged to the client. And at the same time, the blocks which are getting dirtied in the memory by all this transaction will be written to a disk, but that goes in asynchronous fashion. And finally, the checkpoints will be happening. So there are multiple Postgres process involved, the checkpointer and background writer. At the same time, there are dedicated process which deals with the VAL part only, the VAL writer and VAL center. And at the same time, there will be VAL receiver at the standby side. So today, this presentation is all about the VAL part of this, because we cannot deal with the entire picture. Yeah. So this to give the overview. So we are going to see only that box part, the red box. So why VAL? Oh, the answer is very simple. The memory, the RAM is volatile. Anything you write to RAM, if the server crashes, it will be lost. Very simple. And durability of transaction need to be assured by a database. So if you look at the Wikipedia definition of durability, it guarantees that transactions have committed will survive permanently, whatever happens. So that's what expected from a database. So that's where the VAL comes into picture. And so even in the, currently in the chat, there were many questions about high availability and all. So this is how the overall journey about the VAL. So all high availability is all about durability. The data you committed should be available always and should not be lost. So any Postgres high availability solution will look like this from top. So application will be writing to the primary, and the primary will be writing that into its Postgres data files asynchronously, and most importantly, the PG, the VAL file. The VAL files will be the primary place where the data transaction will get committed. And it won't be staying there. If it is staying there, if that disk crashes, you are going to lose the data. So we need to have some external mechanism. That's where we take that to archive destination or stream it to standbys. So the high availability or the durability altogether is all about the journey of VALs from the primary till the standby or the backup or wherever. Yeah. So at the very basic part in the previous screen, we can see that the VALs is getting archived. So if there is no archiving happens in your system, please do it immediately, because that is ensuring the second level of protection for your transaction. So always the VAL should be archived. So those who are coming from Oracle background, it will be clear, because redo need to be archived. So that happens with other database systems as well. And this VAL archive will serve three purposes. It's part of the backup, and it is mandatory for point in recovery, and all the standbys may need it in addition to streaming it. So if something happens to the continuous streaming of VAL to the standby, the standby should be able to get it from the val archive. Okay, so basically there is two parameters which is controlling the archive mode, which tells Postgres please archive the vals, and there is archive command which can execute any custom scripts and the commands. So this is the basics, the very basics of the val. So we are getting little more into the val. This is a common confusion point for many users who comes to the Postgres for the first time. In many database systems, we have the redo groups, and it works like a cyclic fashion. Okay, rise to the first redo. Once it is filled, go to the second one, then third one, again go to the first one. So we have many database systems doing that. But in Postgres, we don't have the cyclic val, the redo. We have a linear the val record. So it is address space of 8 bytes. 8 bytes means it is going to be 16 exabytes. So normally you are going in lifetime, you are not going to exceed that. So that's a astronomical big number. And each record in the val is identified by LSN. It's a logical sequence number, and it is 64-bit. So it's ever growing number. And so as we see, since it's a continuous address space, the system may find it difficult to handle. So there is some logical way of dividing it. So we generally divide that into segments. So by default, we have a 16 MB size, the val segments. So we need to understand it is not the real val. It's only a part of the val. It's a segment of val, and we are logically dividing it into segments. So and we can do it even if it is 16 MB by default. From Postgres 11 onwards, we can change it using the val segment size at the time of initialization. If there is a lot of if it's a heavy system with a lot of transaction happening, we would recommend changing that to a bigger value, 512 or a bigger one. Yeah, and we have many customers doing that, and they are getting direct and indirect benefits out of that. Okay, and yeah, and these big segments contains the val records, the LSN which we mentioned earlier. Those are the actual records. And when we see the first pitch, the diagram, we saw that first the val records are written or created in the val buffers. That's a place of birth of the val, and then it will be moved to the val segments. Okay, and for any crash happening at the Postgres level, the val replay starts from something called redo point, which is associated with the previous checkpoint. The last checkpoint will have a redo point. From there, all the vals will be replayed, and there is some smart mechanism by which many of these redos can be skipped, because we'll see that. And okay, so the val contains the val records. The val segment contains val records, and each record is related to one change in the one type of transaction, one type of change in the system. So, and it has a header associated with that, and each of those header defines a resource manager. We'll see later on what type of record it is. And there is Postgres does something called full page writes. So the val records can be a full page writes or a regular val records. The full page writes happens to recover from to ensure the recoverability of the database. So if after the checkpoint, if the page is getting modified for the first time, then the full page will be written into the val, so that after the checkpoint, we have the confirmation that we can recover the database, all the changes. The full page is available in the val. And since we have multiple types of val records, there was confusion initially because the Postgres source was getting complicated, and we standardized that val record format in Postgres 9.5. So the code is much more cleaner and things like that. And this is so I was doing some compiling of all types of the val records. So these are the types of val records. It's a big list. No need to go in detail. But at the end, we can see that there is something called generic val records. So this is the beauty of Postgres. Postgres is extensible. We can add custom indexes and things like that into Postgres, which can produce a generic val record, and it can be transmitted to standby. So the real meaning of open source, you can modify the Postgres the way you want if you have the code level expertise. And the last one, the logical records, which records additional information in the val for decoding, for the logical decoding. This is part of the Postgres, the logical replication. Yeah. And yeah, so obviously the question comes, what type of information gets recorded into the val? By default, the val level is set to the replica, means the Postgres writes enough information to the vals for a recovery, for an archive recovery. You can take a backup or archive and recover the database. So that val contains sufficient information to do that. But there is a minimal, we can set the value to minimal, so that Postgres will do very minimal val logging, that to just support a crash recovery. That's a bare minimal val level. And in the opposite side, we can change it to the logical, which adds a lot more extra information so that logical decoding can be supported. So we have the control what need to be written to the, how much data need to be written to the val. Based on the requirement, we can change it. And so since we are talking about the commit and the transaction, this is the overall control flow happens in Postgres. First, there is an entry to PG exact. The commit log entry will be made to, so PG exact is just an example. There is a multi-transaction and sub-transaction. Postgres has a lot more complexity to handle. This is very generic, the bare minimum transaction, where the entry goes to the PG exact that records what type of that initiate the transaction record. Okay, it's so it's called commit log. It is a 8K page, and the PG exact is the directory where this will be written. And basically it's a memory area, 8K page, and it's a continuous array. Data will be stored in that array, mentioning that what are the transactions. So looking at this, we can, the Postgres can say what are the transactions in progress and how many are committed, completed. Yeah. Once this commit log entry is made, the Postgres modifies the pages, we call heap pages. It will be modified, and corresponding val records will be generated, and the val records will be in the val buffer. And here you can see it updates the page, the heap page with the LSN. Okay, because the heap page records the LSN, and that can be utilized for crash recovery, because Postgres need to know from where the crash recovery need to start. So if the page contains a LSN number which is higher than the LSN in the val, those records can be skipped because the page contains the latest information. So the Postgres can speed up the recovery. And as we discussed, Postgres does continuous background writing and checkpointer. So generally, most of the information from the last checkpoint till almost near the crash will be there there is a higher chance of that recorded in the pages. So the crash recovery can speed up. Yeah, and if the transaction commits, the val commit record will be written into the val, and of course there is a flush happens. That's how the durability is ensured. Flush the val buffer, and once the transaction is committed, then go back to the commit log and change to status from incommitted to commit, in progress to committed. This is the overall control flow happens in Postgres. And when it comes to what type of synchronization happens with the disk, first of all, the flush, the fsync call happens only if the parameter fsync is on, and we must make sure that it is on in Postgres. Otherwise, you may end up in corruption. And unfortunately, there are a lot of materials online and people recommending to turn fsync off, which is a way to tell say, please corrupt my database. So never do that. Fsync must be on. And the synchronization, what are the types of synchronization? Flush, the fsync, the OS can support. All these things can be selected from the Postgres as parameter. The parameter name is valsync method. In Linux systems, the default is the second one, fdatasync, which means write the flush only those data and the basic metadata about that change into the file system. So instead of completely flushing the entire metadata of the file, the inode, and there are a lot of metadata about the file, the change, access time, modified time, change time. There no need to write everything. Only those if extra pages are inserted, okay, those pages and the reference to those pages. The very basic things. So fdatasync is the default in Linux, which can speed up the things. And we have a lot more options. The default fsync is there, and fsync right through the disk cache, and the system call like direct open also available in Postgres. So the user has the ability to choose, but the default is good enough. But please understand that it does the minimal and optimal writing. And in general, the Postgres does a lot of buffered I/O. The buffers, the blocks are modified in memory, and it is written into the cache. The kernel, it can be the OS cache or write back cache, or at library levels, libc level, we have caching. So the background writing or the checkpoint writing goes through all this cached writing. So, but when it comes to val, it cannot afford to have all this caching. So it need to do more direct kind of writing. But the storage write cache may exist there, but if it is not battery backed cache, better avoid that using write through. It need to be really almost direct writing. But again, coming back to the direct IO, Postgres has val direct IO option, but it won't be doing in general case because the val records are further required to be propagated to the standbys and archives. So if it is direct IO, again, it will result in reading the same thing again. If it is available in the OS cache, or somewhere, it is easy to read, and it speeds up the things. Yeah, so this is a little more internal. So the val record preparation, everything starts with this internal function. Since the data need to be written into the val segments, so many sessions, so many concurrent sessions updating that val segment will be a problem. So it is protected by locking methods, locks. By default, the xlog insert lock is set to 8. There is a lot of discussion, but it is not user changeable. And in the community, there is an agreement that this works best for most of the users. But in case you need to change for your extreme machines, you may have to change this at the code level. But currently, we don't have any other option than so. The logs are acquired to get the position. Okay, as you can see, there is the entire process is two-step process. First step is reserve the right amount of space in the val and then copy the record. So if there are multiple processes are involved, everything should not clash. So the reservation of the space and things need to be protected by the logs. So there is 8 logs by default. And of course, there is if there are more logs, the overhead is more to find out. There is some optimizations done. If the same process is going to take a log again, it will try to acquire the same log which was used previously, so that it don't have to scan through all the available logs. So there are a few optimizations in the code. So lesser the log, the overhead is less, but yeah, there could be some level of contention at the extreme load conditions. Okay, and finally the xlog flush. So the fsync supports, as we saw, there is a multiple flushing methods, and always make sure that the fsync is on. I repeatedly saying that because it can lead to corruption. And the val, once it is committed to the val segment, the journey is not ending there, as we discussed. This is a part of the finishing segment. I just took this code to explain what are the further steps happens. The val sender wake up request. It's basically telling that, okay, the val sender to get up and you have something to do with there is some work came. And then it need to notify the archiver process using a notification. And optionally, there is in special conditions we need to do the checkpoint also. So the val sender and archiver are asynchronous. So because they will be lagging. If the archiving is happening to some, for example, cloud bucket, it could be slow. So it could be lagging behind the val generation. So it may take some time. So asynchronously it need to be notified. There is some working. And Postgres does it, this notification using a mechanism called, it's basically creates a file, .ready file in a directory in pgval. So the archiver can come and look into this name of the .ready file and understand what are the val segments it need to be archived. And once it is archived, it will change the name from .ready to .done. So it's a very, it may appear as very crude method, but it really works wonderful. This is an asynchronous way of communicating with the archiver. And as I mentioned, the archiver can be any custom script as well. And the val centers, of course, val centers basically tells to wake up, and it basically reads from the disk on the primary side. And each val center will be sending that information to one recipient. Yeah, and it works like normal Postgres connection. When a val receiver connects, the val sender one val sender starts, and it sends the val records over that. Instead of replying to normal connections, will be replying to queries. Instead of that, the val sender will be sending the val records. Yeah. And so as I mentioned, why the direct IO is avoided, because it need to again read from the disk. It could be it may lag, and if there is a cache, it will speed up the things. So this is one thing which very interesting for many of the users. Postgres supports asynchronous commit. Okay, basically it tells that the reply the commit back to the client without actually writing, without flushing to the disk. Okay, which is against the concept of durability itself. Postgres comes back and tells, okay, it's committed, but we can utilize it for optimizing a lot of areas. For example, if it's a banking transaction or very critical part of the transaction, we need to ensure that, okay, it is committed and coming back, really return to the disk. But if it's some kind of logging or auditing, or there are a lot of things happens in the data. So there is a bulk data loading. We discussed about the migration. So many of those things, in a system, 75% of the workload may not require a synchronous commit. The commit can happen immediately after some time. The Postgres can acknowledge back the client that, okay, proceed. So Postgres provides to control these even at the session level and even in the transaction level. So if I have a block of statements, say do the transaction, okay, which need to be doing synchronous commit, then all the logging and auditing, okay, this transaction happened to some other, that need not be happening in a synchronous fashion. So only that main critical transaction portion can be doing a synchronous commit. It can be the statement is set local. Set local means within the transaction. So once the transaction commits, it will be asynchronous again. So those people who want to take the maximum out of the performance from the servers, they can tune this to the best level, catering to their requirement. Unlike fsync. So as I mentioned, fsync, if you turn it off, you may be corrupting the database, but you can safely turn off synchronous commit. This won't be affecting the integrity of the entire database. So it means it won't get corrupt. But the last few transaction might be lost. If it is not critical, you can, if you are afford to have it, yeah, this can be done. It can be set at the user level, or at database level, or at a session level. Yeah. And there is these parameters has some implications. So by default, the synchronous commit will be on, and which means if there is a synchronous standby, that val record will be returned to the standby. The primary can send the val record to the standby and getting an acknowledgement that it is returned there, but it is still wait for the flush also to happen if it is on. And if it is apply, the primary transaction will wait for the remote write, flush, and apply the transaction there, so that the same information will be available to the standby or any user connecting to standby. And the third one, the remote write, which is the best in many cases, where we need to ensure that the val records are available in the standby side. So it will just do a remote write. The flushing and apply may happen later on. So a lot more speed up can happen. And the other option is local. Local means do only local commit. Yeah. So these are the areas where the fine tuning based on the requirement can happen. Yeah, and going to the last slide. Yeah, and this is another obvious question. So, okay, if you are turning off the synchronous commit, how much of data you are going to lose? Okay, the answer is this: last 200 milliseconds data, because there is a val writer delay, which is the default value is 200 milliseconds. The val writer will be writing in every 200 milliseconds for sure. So it will be written. Or at 1 MB size, if the system is generating 1 MB val, it will be definitely written. So if there is a asynchronous commit, not synchronous commit, the maximum data loss will be this much. But in a heavy system, in a very high transaction system, you may lose data up to 3 times of this val writer delay, because there is optimization in the val writer to write a bigger page. Yeah. Otherwise, it's 200 milliseconds is what I lose. And this is a commit delay and commit siblings. So unlike the asynchronous commit, this will ensure that the data is persistent, but it delays the commit so that it can commit lot more parallel things at a time. So if there are 10 sessions and they created 100 val records, and all those things can be committed at a time. So all the clients may experience a slight delay, which can be controlled by this commit delay, but it will get acknowledgement only if it is committed. So it's a balance. This also can be tweaked. And the common mistakes. We see that many places the val archiving is not happening. It is not turned off, and surprises happens, and the database is not recovered. Please make sure that the val archiving is happening. It is part of the durability, and fsync should not be off. Fsync must be on. Please make sure that it is on. Otherwise, database may corrupt. And the consumer grade storage. In the community, there is a lot of discussion about this because many storage acknowledge back that it's written actually without actually writing. So, but in reality, I didn't encountered much of these issues. But the fourth one, the virtualization impact, that's a lot of people get into this problem. There are well-known virtualization solutions which won't actually give the 8K page properly to the underlying host operating system. Instead of that, it will only give the 4 KB first. And if that server crashes at this time, the page will be tiered. Corruptions happens. Yeah, it's reported widely. And the last one, the val log hints. Preferably make it on because many of the rollback, the PG rewind kind of things request this, especially people were asking in the chat that how Postgres HA works. So Postgres HA requires joining the node back to the cluster again after a crash. So the rewind should happen. So enabling the val hints or enabling the checksum will indirectly make it on. So enable the checksum so that the corruptions can be avoided, as well as the val hints will be, the hint bits will be val logged. Okay, and some good references. Yeah, that's all from, hope this is interesting, at least something take away.
Thank you, Jobin, and we appreciate you sharing your presentation with us. So lastly, and thanks everybody for sticking with us, we have one more talk from Robert. So Robert, I will hand it over to you, and thanks again, Jobin.
Thank you.
Okay, and you tell me when I have the main screen. I still see the slides.
Okay, just one moment. Jobin will
Yep.
stop sharing his screen.
Where should I? Okay, stop sharing.
Okay,
sorry.
should be.
All right, let's see. Here we go. And yes. Good, let's maximize that. And you can see me?
We can see you, not your screen.
Okay. No, I'm going to share the screen now.
Okay.
Just bringing that up. Yeah, I'm just with my guys there on the Millennium Falcon right now. And this should do it. Oops. Right. We good?
Yeah, we're all good.
Excellent. So it is now 9:35 a.m. I have my second coffee in my hand. And hopefully I won't sound too hyper with the second coffee in my gullet. Okay, this presentation is going to be about an introduction into what's called the PG Crypto Contribution Module. And it's a very basic introduction, what I want to do. And I like doing these kinds of talks because it helps sharpen me about the basics. There are concepts to learn. The concepts, when it comes to encryption, is actually quite sophisticated, but its implementation in Postgres is quite simple. The PG Crypto module has actually been around since almost as long as Postgres has been around, when it first was open sourced in the 90s. What it is a suite of function calls, procedures that allow various functionality using under the larger umbrella of encryption. And what we're going to do is basically go through a very basic, how to install it, recognize what certain features are. Basically, this is about concepts. The concepts are the harder things to wrap around. So again, reiterating, it's a collection of functions. It permits you to create and administrate a database system capable of handling encrypted data. So we're beginning here. As usual, I use my preferred distribution is Ubuntu because of the libraries, the versatility available in the environment. And I'm using the most recent version, which is Bionic. Installing everything as per the download process. And in this particular case, what you'll notice is we're, in addition to installing the standard libraries of Postgres, we're installing the GNU PG2, NetTools, and Systat. NetTools and Systat are for my own edification. They contain utilities that help me monitor the system as it's under load, as it's being used. The GNU PG2 is actually the encryption libraries that allows you to use some of the features that PG Crypto uses. It assumes that you're going to have PG Crypto on your server, and it enables certain particular concepts like public key encryption. So we check our server, it's active, and we log in. We're going to create a little database called demo. And when we're in demo, we're going to create an extension called PG Crypto. This is the list, the most recent, of the implementation of all the function calls used in the PG Crypto. Now, the thing you need to understand is what we've got are a collection of functions of concepts that were developed over the years. What Postgres did was it basically pulled in all the concepts at the same time. Some of these concepts, some of these ideas are behind the scenes. Some of them are, these function calls aren't really used as often because they've been superseded by what are now considered better industry practices. What you're going to see is an overview of all of them. It's very helpful to know them because of the ideas behind them. So we've got armor, crypt, de-armor. Like for people coming up to PG Crypto, these are words that absolutely mean no sense. They encrypt, you can figure out. HMAC, HMAC, generate salt. The decrypt, publication, encrypt, publication, public. They're there. So let's go through them. The classifications are as follows: general hashing, passwords, random data functions, raw encryption, and PGP encryption functions. General hashing functions are actually used all the time under the scene. Its most primitive are CRC checksums. The Internet Protocol, for example, when we have packets sent back and forth on the internet, not only is the information, the data sent, but there's a checksum of that data, a representation of the data that is sent with it too. That's why you have slow bandwidth sometimes, because it's your application is going to get these packets. They're going to say, hey, this doesn't make sense. My checksum doesn't equal the data. That means there's corruption, and it'll reload, it'll re-ask for the packet, and you wait until it comes back in. On a more complex, bigger level, if you go to the Postgres site, if you go to our sites, at Percona, you find that when we have downloads, we also include the hash. A hash is a unique fingerprint. It's an algorithm that goes in and it looks at whatever the content is, and it generates an alphanumeric series of numbers that is unique. Now, over the years, we've had different protocols. The most common one everybody knows is MD5, but before that, we had MD2, MD4. Now, MD1 and MD3, they were sort of like, they went up and then they went down. Nobody really knows where they are these days. MD4 was actually a very popular, very fast algorithm generating a hash. It was deprecated in favor of MD5 because of the statistical probability of what are called collisions. That statistically, it was possible that you would have a combination of bits and bytes that would come up with the same checksum that would match something entirely different. And this is one of the issues about when you're doing encryption. You're concerned about people corrupting, changing something. The checksum guarantees it. The MD5 a few years ago was identified as you could generate collisions. Is it practical to do a collision? It depends on the use case. You're talking about people that are very advanced when they're trying to do that kind of a thing. Password hashing functions build on top of the general hashing. You generate a unique fingerprint, say of a password, but in certain cases, you don't want that password to be the same. Like if you have the same password and you generate a hash, when you do an MD5 checksum, that hash will always be the same. And in Postgres, that's exactly how we hash our passwords. It's a username password combination. The hash is not exposed unless you are the super user and can see it. But you can tell that whenever you have the same username and the same password, the hash will always be the same. But when you do a password hashing, that one's different. It uses what's called a salt. And the salt actually mixes things up so that the encrypted form of the password is always different. Random data functions, these are convenience functions. Linux has an implementation. It's the random, I think it's called the random pool. And OpenSSL has a quite extensive library to create random characters. Raw encryption, that's your old-fashioned symmetric encryption. This is where you have a password. The same password that encrypts something is the same password that's used to decrypt. And of course, then you have PGP encryption functions, or GPG, which is kind of confusing because it's either one or the other, and they actually do mean different things. What's important about PGP is it uses checksums, it validates, it puts lifespans on encryption keys, and it uses public-private key encryption, which we'll cover in a few minutes. So when you look at this table here, we see these are all the capabilities of generating hashes. Now, a long time ago, that left column that says built-in, most of that was no. Most of what you wanted to get that functionality was accessing OpenSSL, which PG Crypto actually has a wrapper allowing you to get to the OpenSSL libraries. OpenSSL is the industry standard. Over years, PG Crypto enhanced, built up all those library capabilities to match it. So except for that little section that says other digest algorithms, virtually everything these days is now incorporated into PG Crypto that OpenSSL does. When it comes to concepts, especially when you start learning about using the crypto module, you'll find that the OpenSSL project, when you go online, is extremely detailed when it comes to encryption. It talks about the concepts. I would suggest that you start there. It's a very deep subject. It's something that a person could actually specialize as a profession. So here's our simple examples. I didn't put out the hashes. I just left an example. The function called digest will generate these hashes. Hello world MD5 is of a certain character length and complexity. SHA-256. The RMD 160 is actually one of the older the older hashes. And again, this is available also through the OpenSSL. These come under the category of other algorithms supported through the OpenSSL libraries. They're very interesting. These hashes, remember, whatever you put in for the string, when the hash is generated, will always be the same, no matter what. It's just different complexities, different lengths. These days, with what we're hearing in the industry, reports about hacks and penetrations, we are encouraged to use SHA-256 as much as possible, something that's much longer and greater than MD5. It's for that reason why, as you heard earlier in our talks, Scram has been adopted in Postgres. The challenge there is some of the client applications, the frameworks, haven't incorporated the capability of Scram yet, and also some people they still have to learn the concept. They haven't gotten their head around the difference between MD5 and Scram. HMAC, hash message authentication code. This is old school. It's still relevant. The PGP libraries do take care of this, but this is really, really interesting. You send a message. You can see the first line, my message, hello world. And then you also include a key. You're sending a message in the clear. You're not encrypting it. What you're doing, though, is you're getting a hash of that string, and you're adding a text called my secret key. Now, that could be any string. The thing is this, the sender and the receiver both have this secret key, this pass. When you send a message and you use something like HMAC, you generate a hash, you send the hash with the message, the person receives the hash and the message. And to verify, to validate whether or not that message actually came from you or came from that other person, you generate a new hash using that secret password. The hashes match, you know the message came from them. Now, obviously, of course, this has been deprecated in favor of signing. When you sign the message, the signature is going to be part of it. This is of a simpler time, a simpler feature. And the nice thing about something that's simpler isn't just about understanding. Common sense, it's actually quicker too. It generates much faster. So you have an opportunity if performance comes as an issue. And when it comes to encryption, performance is always an issue. Below you see encoding. We took the first query, and what we've done is we translated it into a format that could be stored as a byte A in Postgres, or if we had to, as a data type text. Encode and decodes are actually the basis of how emails used to be sent, how it converted binary information into readable format. A long time ago, email could only do 7-bit, which meant alphanumeric, and that was it. Armor, you might recognize this. When you generate a public key, when you have a private key, when you generate messages, if you've ever looked at them, you're going to see it's going to say begin PGP message and PGP message, and then you're going to have your combination of alphanumeric. This formats it. It makes it storable, and it makes it possible to send it through different mediums. Again, the old email standard was 7 bits. Other password hashing. As I said before, you want a password. You want to be able to generate it. It's very useful if you have an application process. Because of the protocols, even though this is a Postgres-specific functions, you should be able to find the same corollary in Python, in Ruby. The libraries are comprehensive enough that when you generate your password, and you can find out what the password is, you can validate it on the other end because the libraries will be there. Now, in this particular case, imagine you have a credit card. Well, we have a concept called translucent data. Never store credit card numbers, never store social security numbers, for example, in a database. Instead, store their hash. If you can, do not store them as standard hashes because they'll never change and it's possible to do brute force. Instead, use the password hash, which will generate a unique hash of the password every time you strike it. In this particular case, as you can see on the slide, we ran these two sets of queries twice. We used the same password, we used the same message, and the hash password actually came out different. And you can see in both times that when you use it, you can validate it. So if somebody sends, say, credit card information online, it's going to be hashed on his end. It gets sent. If that hash is then validated by comparing the hash there. And those two hashes, even though they're different by the algorithm, they can be compared, they can be matched. Random data functions, encode, decode. You notice the function, generate random bytes. OpenSSL has always had this ability. And if you know a little bit of Linux wizardry, you can do the same thing. You can create random combinations of characters. Again, very useful when you are involved in the whole idea of creating encryption, or in our case, in databases at Percona, sometimes we do benchmarking. And when we benchmark using data, strings, this is the easiest way to generate random data. It forces us to use unique data information to check out the performance of loading and unloading instead of letting the system trying to find matches and making it simpler. UUIDs, they used to be rare birds. Now they're pretty common. Universal, unique universal ID identification. Postgres, for the longest time, you would use a type serial, an incremented number. However, when you start having sensitive data, one of the rules about encrypted data, for example, is you refer to identification numbers, the IDs, which are going to be classified as primary keys. However, you don't want sequential. Sequential is a pattern. Patterns are a weakness when people are trying to hack or understand your system. So you use universally unique identification. If you notice, there are actually 5 versions. There are actually different standards of generating UUIDs based on what your needs are, based on performance, based on bandwidth. Some of them are completely random. Some of them, they pick information like date stamps. Some of them use the MAC address. The interesting thing about a MAC address is that when you do that, you could come up with some interesting hash tables when you partition tables. As you can see here, we're using an example of version 4. PG Crypto has been here for years. You've been always generate UUIDs, and the older implementations of application servers and Postgres use this functionality. However, these days you can also generate UUIDs because now they've been imported as general functions in the most recent versions of Postgres. So you can see here that every time you run the random UUID, you get something new. Raw encryption. Please pay attention at the look at the bottom there where it says attention. Again, PG Crypto module doesn't incorporate just cutting edge. It incorporates all the major concepts that have been developed over the years. This form, encrypt, decrypt, is what's called symmetric encryption. And on our level, we try to discourage it because the password that you use to encrypt is also the same password that you use to decrypt. Also, you'll notice that you can't do integrity checking. You can't prove that it has been changed or hasn't been changed. You can't sign it. And of course, that little last point there, not handling text. If you look closely at the query example, it was created in the table, populated the table, and we pulled it out. And we had to use an encode and decode, and we had to coerce it between byte A and text. The PGP encryption functions actually handle this. You don't have to do this fancy casting. So let's talk about GPG. you're going to have to install and generate public-private keys. We're assuming that you're on a Linux machine. You could do this on Windows, but it's easier just to demonstrate on Linux. You are going to install it. You are going to generate keys. Then there's going to be a little interaction. You're going to say, okay, who are you? What's your email address? What's the ID? And then it's going to create your full key. You can review it by using the list key. Now, in this particular case, let's look at an encryption. This is, again, simple, symmetrical. Password to encrypt, the same password to decrypt. You can see here, we have a secret message, we have the password, and we take it out, and it comes out again. Again, this is the favored method. It is the most modern method. It is the recommended method. And all these libraries are supported in all versions of Linux. Here's a little interesting example using asymmetrical public key encryption. Remember, we generated our public-private keys. Well, we need to use those public-private keys. The public key is one way. You use the key to encrypt the message. The sender no longer has the ability to decrypt that message. The only person that can do it is the one who generated those keys. The person who reads it, best case is that when you read data that's been encrypted, you never have the private key on the system. Instead, you read it into your application process. The application process then decrypts it in real time. Then from here, you can see, in this case, we're using PSQL. Let me show you right here. So here's a command, gpg list secret keys. This is the public-private key that we created. User1 at myemail.com. And you see this long alphanumeric combination string. That's how we're going to export our keys. Look down here, gpg2 in ASCII format, you're going to export it. And this is the fingerprint. This is what we're going to use to pull it out. You can have an entire collection of public-private keys in GPG, and it'll just pick out that one, and we're going to pipe it into a text file. Same thing for the private key. We do this so we can do our little demonstration. We're in a PSQL session. Set public key. Now we're going to assign a variable. If you remember your PSQL, the meta command is we're going to create a variable called public key. We're going to create a variable called private key. I'm separating this out for the purposes of clarity. 4 single quotes on the left side, 4 single quotes on the right side, and in here is a backtick. This is bash. So I'm going to cat robber.ask.text, and that's going to go into public key. Private key, we're going to do the same thing, 4 single quotes, backtick, cat robber.secret.ask.text, and that's going to be put into the private key. We verify by just doing a selects, and you notice the colon. Again, this is all Postgres stuff. It's all standard PSQL. Now we encrypt. We're going to do PGP public encrypt. We're going to use the public key. Notice the function called de-armor. So there's our message. We use our key, de-armor, and we're going to put it into a table. We're going to call the table encrypted message. Now we decrypt. We use the PGP pub decrypt. Notice that we're querying the table. Select message from encrypted message, and we're using de-armor. Notice this time, private key. We use the password because when we created the key, we had a password to keep it. Good practice. Don't lose the password. Don't sign keys without passwords. And you can see here, it outputs my secret message. Nice and easy. Performance issues. A long time ago, I was at a talk with Rasmus, the creator of PHP. He was working for Yahoo at the time, and they ran into performance issues when they had Postgres as a back end. It turned out that they had SSL enabled by default, and they didn't realize it. Encryption hits CPU. Always remember that. When you use it, you must take it into consideration. In these days, it's a necessary evil, but there may be use cases where you can decide, where you can choose not to use encryption. The rule of thumb is general data. If you want to decrypt, that's a judgment call. Administrative tasks, when you're logging in as a super user, when you're doing replication between master and slave, or these days, primary and standbys, replicas, that's always encrypted. Always beware of the costs. When you do individual pieces of information, again, the concept translucent data. If you can, never, never save the actual information. Save a hash of that information. That's sensitive. Public key encryption, policies, common sense. One of the things that is not done is putting lifespans on keys. Always put a lifespan. But keep in mind, if you put a lifespan on data and you exceed that lifespan, you're not going to be able to access that data because your key will no longer be valid. You'll have to do some crazy tricks. So a good practice is to have multiple keys assigned onto your sensitive data, allowing more than one private key access to the data. Symmetric key encryption issues. This is the secret password, where you have the same password encrypting and decrypting. So always watch what you're doing. It's all common sense stuff. Again, what I like about going through these presentations and these talks is it helps me remind myself of the basics. Never forget the basics. And that's it. Thank you very much for your time. Take over.
Okay, thank you, Robert. And a big thank you to all of our presenters for today. That just about wraps up everything, or all the sessions that we have. If anyone has any other questions, feel free to ask the questions on Slack, and one of our Postgres team will get back to you. So we appreciate you all joining in on the Tech Day for Postgres, and we hope to see you at one of our online events soon. If you subscribe to our channel, you can stay up to date with the next online events taking place over the next few weeks and months, or stay tuned to our blog and website. Stay safe, everybody, and thanks for tuning in.